Hello everyone. Today we will talk about imaginary numbers. So what is imaginary numbers? So when we solve something like, let's say, x squared equal minus 1, and we take the square root of both of those things, we, as human beings, we don't know what exactly is this. So we invented something called imaginary number to understand what is this, okay? And we have real numbers and imaginary numbers. So, for example, guys, the imaginary number, as we said, we defined it as the square root of minus 1. So, if we take to the power 2, then it will be minus 1. To the power 3, it will be what? It will be minus 1 times, square root of minus 1. So, it will be at the end minus I, right? And if we take the if we take to the power 4, for example, we will get minus I, which is this guy, times I, okay? And this will be minus I squared. And minus I squared is minus 1, so it's going to be equal to 1. And 5 is going to be I, because to the power 4 is 1, and to the power 5 is going to be I. So, the addition and subtraction in the imaginary number, okay? So, let's take an example. Let's say we have 4 plus I plus, let's say, 1 plus 2I, okay? Just for an example. So we will take the real numbers, okay, and add them together, so it's going to be 5. And we will take the imaginary numbers and add them together alone, and it's going to be 3. Same thing with subtraction. So something else we see, multiplication and division. So in multiplication, let's say we have here A, and here the imaginary part, and here C, and here the imaginary part. So this guy with this guy, okay, sorry, and this guy with this guy, then this guy with this guy, and this guy with this guy. So we get like this, okay? So let's take an example. And division, we actually do this rule, like we take this guy, but we don't put plus here, we put minus, and multiply and subtract at the same time to the same equation, and we solve. Okay, so let's take an example. 7 plus 5.2i divided by 3 plus 4i. So we'll take this. Let's change the color. So we'll take this guy. Okay, we'll take this guy. Okay, and we will say 7 point. This is 7. Sorry, 7 plus 5.2 divided by 3 plus 4i, and here is the thing, and we divide that thing with 3 minus 4i divided by 3 minus 4i. So this is gonna be 7 plus 5.2 times 3 minus 4i divided by this guy, and here we will get 9 and here is minus 16 I squared. And I squared, guys, what we said? We said I squared is minus 1. So we will remove that guy and put minus 1 here, okay? And let's remove them all now, since we know already it's a minus 1. And change it here to plus. So, and we continue, guys, and continue the operation till we get the final answer. Like, let's say, let's, for example, plus 16 is 25. Here's 25. Yeah, sorry, here I. And in the above we say 7 times 3 minus 7 times 4i, and here 5 plus 5 times 3, 5.2i times 3, and here is minus 5.2i times 4i, and you just solve that. Anyway, guys, so we have something called the polar form. So, guys, what we take above, like this form, this kind of forms, we call it rectangular form. And we have something else called a polar form. So a polar form is basically, we are seeing, like, see this 2D map, okay? We are noticing that we can also know the position of x and y by using r and theta. So basically, if we know theta and we know r, we can find or know the position of our value. So how to convert? We convert by this formula. So x plus y, I equal to r cosine theta plus I sine theta equal to r e to the power I theta. Okay. And if we want to get back to the rectangular form, we take this those rules for x and y. So how do we know theta? We know theta by tan inverse. And how do we know r? We know r by this formula. Okay, so let's take an example. Like, this is a rectangular form. We want to convert it to polar form. So we're gonna know what is r. R is 4 square plus 6 square. It's equal to, let me use the calculator, 4 square plus 6 square. It's equal to 7.2. So it's 7.2. And theta is the tan inverse of this, 6, 4. And it's gonna equal to 5, 6 degrees. Okay, so this is how we know, and we're just gonna apply this here and write it down. So now we know the value of it in polar form. So here we have Mover's equation and Euler's equation. So Mover's equation, that anything in rectangular form to the power n can be written also in polar form to the power n in that formula or in that way. Euler's equation also that tells us that e to the power I theta is equal to cosine theta plus I sine theta. And same thing with minus I theta, like e to the power I minus I theta is equal to cosine theta subtracted from, this is I sine theta. And we can find cosine theta and sine theta by those equations. So let's take an example. If I is equal to the square root of minus 1, which of the following is equal to I to the power I, okay, or j, whatever he names it. So that's easy, guys. So we said, let's analyze this, okay? So this is basically, what is this? This is 0 plus I to the power I. But let's keep that away for a bit. So 0 plus I is actually equal to what? Like the r of this is equal to 0 squared plus 1, the coefficient of I, 1 squared, and it's equal to 1. So r is equal to 1. R is 2. And theta, we can know theta if like we see the 2D word. So here is the real numbers and here is the imaginary numbers. So the real is equal to 0, the real part here is equal to 0, so we are here. And the I is equal to 1, so we are here, okay? And the degree from here to here is 90 degree, which equal to pi over 2. So we know now the theta. Theta is equal to pi divided by 2. Okay, so we now gonna do our Moivers and Euler's equation, okay? So we're gonna say that 0 plus I is actually equal to r a I theta, right? Like this is the definition of, like, if we go here, let's go here. Like we said this, guys, you remember? This is equal to this, right? So if this is equal to this, then if we add both of them, I, and here I, and you will say this is 1, guys, this is 1, this is 1. So it's gonna be I squared theta, and I squared is what? Is minus 1. So e minus 1, and theta is what? Is pi 2. So we get the answer for this question. Thank you, guys. See you to the next time.